Assalamu alaikum. Good morning, everyone. Thank you so much for joining our webinar. Let us wait a few more minutes to give a chance to other people to join.
Good morning, everyone. Anna, please let us know when we can start, okay?
Thank you. Good morning. I think let us wait until 11:05, so like just 4 more minutes, and then we can start. I will give you a heads up. Thank you.
Okay, thank you.
Good morning, everyone, again. Thank you so much again for joining. We may start the webinar now. As you already see on the screen, Hilti will present today. I believe Engineer Judgement and Engineer Wissam Khoury. Thank you so much, and we can start now. Please note that the webinar is recorded.
Thank you, Anna. So, good morning, everyone, and welcome to our webinar, Firestop with BIM. My name is Judgement. I'm the BIM project manager from Hilti, and today I'll be presenting with my colleague Wissam Khoury, the engineering manager for UAE. First of all, I would like to thank buildingSMART UAE and Dubai Municipality for giving us this opportunity today. And before we move into the presentation, I'll tell you quickly who are we at Hilti. Hilti is a 100% family-owned company, founded in 1941 in Shan in Liechtenstein. Almost 30,000 employees in more than 120 countries around the world. And Hilti is known for offering solutions for construction professionals through our direct sales approach. For today's presentation, I don't think it's moving on the screen. Okay, now it's showing again. Okay, so the aim of the presentation today is to brief you about Firestop. What is Firestop? Fundamentals of Firestop when it comes to life and safety in a building. Why is it needed? What are the approvals or an engineering judgment? When is it required? And what could go wrong in a building using the engineering judgments? Then we will tell you why is it important to have the Firestop in the BIM model of your project, whether you are, and what added value would it have in the project, whether you are a building owner, developer, consultant, or even a contractor as well. So now I'll hand over to Wissam to tell us more about the Firestop.
Thank you very much, Judd, and welcome everybody. So I will be kickstarting the topic of the fire stopping. What I would like to do first is introduce myself. So my name is Wissam Khoury. I'm the engineering manager here in Hilti Emirates. Again, I would like to thank the Dubai Municipality and the buildingSMART UAE chapter for this wonderful opportunity. So I will be taking you through the principles of Firestop, a little bit of basics, and a little bit of practical situations that you might face in the job site. And later on, I will hand over to Jad to continue with how it all applies on them as well. So unfortunately, fire as of today is not 100% avoidable. But the good news is we have four main pillars of fire protection measures in place. The first one is fire protection prevention. And a great example of prevention is exactly what we are doing here today by raising the awareness about fire and how to protect against it. Other things could be like the different global codes and standards that are available worldwide, and the country-specific codes and standards like what we have in the UAE Code of Fire Life and Safety. The second pillar of the fire protection measure is the fire detection. So this is what you are familiar with the fire alarm system, and this consists of smoke alarms or smoke detectors, heat detectors, and the fire alarm in general. Then, when a fire actually happens, you need fire protection measures to try to control it or even extinguish it. The first of these protection measures is the active fire stopping, and this is what we all know as the firefighting system in a building, which consists of sprinkler systems. It could also consist of other gas sprinklers like energen systems. It could also be the fire extinguisher that we hold by our hand and try to extinguish the fire with or try to control it. Finally, we have the passive fire protection measure. Passive fire protection measure is exactly what we are here to talk about today, and a big part of it is fire stopping. So passive fire protection measure are building materials already installed in the building and existent in the building, and they try to delay the spread of fire and prevent it from passing through other areas as well. Now, active fire protection measures, they require an external energy source. So for example, a firefighting pump, electricity, or even human intervention for them to work. While passive fire protection measures, they're there in the building and they do their duty without any human intervention or any external energy source. A lot of people might be asking, so if I have an active fire protection measure in my building, if I have a firefighting system installed, do I need passive fire stopping? Or do I need fire stopping material? It's exactly the same as saying, well, would you need a fire rated door as well? So the whole idea here is that both the active and passive fire protection measure, they complement each other and they work with each other. So both are needed and both of them are working together to ensure the safety in any building. I would like to show you a very quick video that summarizes everything we want to talk about today and that will touch on specific points that are extremely important in terms of Firestop. So we'll watch the video together and then we can move on.
Typically, 5 minutes is all you get. Fire, and especially smoke, spread through a building much faster than most people think. Every year, about 3.8 million fires occur worldwide. While damage to assets is in the billions, the yearly death toll amounts to 45,000 persons. Much of this could have been prevented if correctly installed fire protection had been in place.
Architects, planners, engineers, and building owners are responsible for effective fire protection. Oftentimes, they do not realize that Firestop is not an option. It's a clear legal requirement, and negligence or improper execution is a violation of the law. Nearly 60% of fire deaths are not in the room of the fire's origin, and 3/4 of all fire deaths are caused by smoke. When there are through penetrations in walls and floors, toxic smoke easily spreads to adjacent rooms. The keys to effective fire protection are both active protection, such as detectors and sprinklers, but also passive protection. Passive means that penetrations in walls and floors have been sealed with approved Firestop products. This principle is called compartmentation. When installed correctly, fire and smoke won't be able to spread from one compartment to another. This allows for safe evacuation of people and protects valuable assets. The thing about compartmentation and fire protection is it's only as good as the products you use. You know, one always thinks that accidents only happen to other people. That's a false conclusion. It is the responsibility of architects, planners, engineers, and building owners to protect lives and assets by effective and well-designed compartmentation.
Right. So, some of the points that I would like to really stress upon from this video, because I think it greatly summarizes everything that we want to talk about and the things that we need to keep in mind. But also in the video, it just does not just talk about fire, but it talks about smoke as well. And now we will see how. And it also talks about the correct installation and the correct selection of fire stopping system that needs to be applied in the project site, which we will touch upon within this presentation a little bit in more details in the next few slides. Let's start to recap some of the things that was mentioned in the video and some of the fire statistics that we have worldwide. So we have nearly 4 million fires worldwide. And on average, 45,000 deaths happen per year due to fires. Now, what's really interesting is that 3/4 of the fire deaths that have occurred, they happen due to smoke inhalation and they don't happen due to fire itself. So people do not burn during a fire, or that's not the main cause of death, but it's the actual smoke inhalation. So it's very important to keep that in mind as also a serious threat in a building. 57% of the deaths that happen in a fire did not happen in the same room of origin. So here we are stressing on the idea or on the fact that fire can spread very fast and can still be dangerous even if the fire happened in a completely different location in the building. Finally, 47% of the people that survived a fire incident have mentioned that they couldn't even see 3.5 meters in front of them. So it becomes very difficult to evacuate the building if the fire or smoke has spread already to the parts of the building that you are trying to use as an emergency exit. So this is a simple example of a normal corridor, a very typical corridor, and that's what normally it would look like. But in case of a fire, and if the smoke has already managed to spread across the building, this is what it would look like. So you can see here how the visibility would be hindered, and it would be very difficult to be able to evacuate from that building. So let's talk a little bit now about the fundamentals of Firestop. The main principle that Firestop follows, the global principle that Firestop follows, is called compartmentation. And as we have seen in the video before, compartmentation is simply, if a fire happens in a certain location or in a certain room, we want to make sure that the fire stays in that room and doesn't spread to adjacent or other locations in the building. The reason is we want to give enough time for people to evacuate from the building, but we also want to give enough time for the fire department or the civil defense to come and try to extinguish and control the fire. So compartmentation is maybe what you are familiar as fire-rated zones or fire zones. Consists of two kinds. So you have the vertical compartmentation. So if you look on the picture on the left, if this is a certain floor in the building, we divide this floor into separate compartments. So each room can be a separate compartment on its own. Fire happens there, doesn't spread to, most importantly, for example, the corridor area, so that other people can evacuate safely. The other compartmentation zone could be horizontal compartmentation, and here it is necessary to make sure that every single floor by itself is a separate compartment. So if a fire happens on a certain floor, we don't want it to spread vertically across the building into other floors as well. Now, in any fire-rated zone, if I have a fire-rated wall, there must be some MEP services and some openings inside that fire-rated wall as well. And these would be considered as weak areas in the structure from a fire-rated perspective, of course. So if I have MEP penetrations, if I have a pipe or a duct or a cable tray that needs to pass through that fire-rated wall, of course, the opening in that wall has to be slightly bigger than the MEP service itself. And this is for ease of installation and for the pipe to easily pass through that fire-rated wall. The gap that is left between the MEP service itself and the wall is called an annular space. And if this is left untreated and not fire stopped properly, then it would allow for the passage of fire and smoke. These are considered in our local codes and standards in three main sections. So the first section is the through penetrations. And this is what we have just discussed about all the MEP services passing through the wall. The second pillar is the joints. And in the joints here we consider, for example, the soffit joint or the gap between the block wall and the slab that allows for the deflection in the slab. Other locations could be an expansion joint in the floor or a wall. And again, a great example is the joint between the slab and the facade. Then we have the membrane penetrations. Membrane penetrations are a little bit similar to the through penetrations, but they are services that don't pass through the wall, but they only pass through one side of the wall. And a great example of that is the electrical boxes. All of these locations are specified in our local codes and standards on how they must be fire sealed properly with all the acceptable global standards that they must adhere to. Now, when we talk about fire stopping, there are multiple criteria and characteristics that we need to take into consideration. These criteria and characteristics really determine how well our building is going to be safe and how well the fire rating will be achieved. So going back to the example of the MEP penetration, if I have a pipe passing through the wall, there are multiple things that I need to take into consideration. Number one is, what is the base material that this MEP penetration, or let's take the pipe here as an example. So what is the base material that this pipe is passing through? Is it a concrete wall or a floor? Is it a gypsum wall or a concrete wall? All of these that I will mention now in this slide will make a huge difference in your selection when you want to consider a fire stopping system. So we talked about the base material, then we talk about the MEP penetration. So is it a pipe or is it a duct or a cable tray? Each one will behave differently in case of a fire, and each one will need to be considered in a different manner. And even if we are just talking about pipes, we need to take into consideration, is it a combustible pipe or is it a non-combustible pipe? Take it one step further. So even if it's a combustible pipe, are we talking about a PVC pipe, HDPE, or PPR? Because all of them have different reactions to the fire and different rates of combustibility as well. Then we move and look at the different dimensions. So we look at the dimensions of the wall, we look at the dimensions of the pipe itself, for example, if it's a 4-inch or a 6-inch pipe. We also look at the dimensions of the thickness of that pipe. And finally, and most importantly, what is the annular space that is present when we are talking about this MEP penetration? After we have taken all of this into consideration, then all of these need to be applied and need to be matched with an approved tested system. And what do I mean by an approved tested system? So basically, any supplier that wish to adhere to the global codes and standards need to test their products in a third-party approved location like the Underwriters Laboratory that I'm sure you're all familiar with. So what they need to do is they actually construct the wall, they actually pass a pipe through it, they leave the gap, and then they apply their fire stopping solution. So it could consist of, for example, sealant, rock wool, wraps, and other fire stopping products. All the thicknesses applied and every detail and specification of these fire stopping components will be tested as per the recommendation from the supplier, and then they test how long it would take for the fire and smoke to pass to the other side of the wall. If it takes 2 hours, then they would give the system a 2-hour fire rating. If it takes more, less, all of this will be recorded in the fire stopping system. Now, in all the global standards, whether it's American, European, or any other standards, any application that you will have in the job site will need to have a relevant or a matching tested fire stopping system from an approved lab. In the UAE, we know that the 2 approved global standards are the American system, that could be ASTM standards or UL standards, and we have the European standards, which are referred to as EN codes and standards, or the EN approvals. And these are the 2 only approved standards here in the UAE. Taking it one step further, there could be some additional testing that is required as per the designer or as per the client, and these would include that their fire stopping system must have some acoustics rating as well, as an example, or they can take into consideration that whatever system I am trying to create would be under, let's say, movement, would be under movement. So I want to make sure that my fire stop system has that movement capability as well. So all these additional attributes can be asked for and can be provided by any fire stopping supplier if they are required in your projects. So I have been talking about a fire stopping system, and I have mentioned already that any case that you have in the job site needs to have the exact same setup as what has been tested in a third-party lab. Now, there are thousands and thousands of systems worldwide to be able to try to match any situation that you have in the job site. But in some cases, the situation that you have the job site or the as-built situation doesn't match exactly 100% the tested system. Now, the local codes and standards, as well as the global codes and standards, would tell you that in these cases, if you don't have any matching system, then you need to refer to an engineering judgment. An engineering judgment is a paper that is constructed by a fire stopping professional, either from a consultant side or from a supplier side. However, it should be based on tested system and should be backed by tested system. So if I have any small deviations, I can refer to an engineering judgment, yet it should not be used instead or in lieu of a tested system. I will show you an example of what a typical UL system looks like. So this is a fire stopping system that is based on the American standard and has been tested by the UL third-party laboratory. So it has a unique number, which you see here, CAJ1421. It has a brief description of what this system represents. So this is for a metal pipe passing through a sleeve in a concrete floor or a wall. And it provides you either 2 or 3 hour fire rating, depends on some parameters that we will see later on. Then it would have a sketch or a drawing to show the different items in that fire stopping system. So you can see that number 1, it gives you a description of the floor or the wall, and this floor or wall can be 2 hours or 3 hours fire rated, and it could also be a block wall. Number 2, optional to have, is a 6-inch diameter steel pipe. And then number 3, which is the penetrate, and this is very important, this is telling me that I can use this system for a maximum 4-inch diameter steel pipe, or a cast iron pipe, copper pipe, steel conduit, or EMT. And you can see that even if I'm looking at a steel pipe, it's also considering what is the schedule of that pipe as well. Then we look at number 4 and 5, which is representing the fire stopping solution for this specific case with this specific annular gap. So here it says that it consists of some rock wool and some fire rated sealant as well. Now, we said that if you have an as-built case that does not match any tested system available, then we refer to an engineering judgment. And we said that this engineering judgment has to be based on tested system that is similar in nature. Now, the problem is that engineering judgments can be misleading and could cause a safety risk if they have not been designed properly. And that means, as any person receiving an engineering judgment, they have the duty to make sure that this engineering judgment is based on correct data and on sound data. Otherwise, you'd be putting the risk of the people, of the occupants in the building, in danger, and it could cause some serious risks later on. These engineering judgments have to be project specific. So every job site, for every case, they need to have clear statement that this is used for which project and for which application. Now, when we were talking about the different items that we need to consider for fire stopping, we said that we need to take into consideration, for example, if it's a PVC or a PPR pipe and the different dimensions. But something that is very critical as well, we also need to take into consideration whether this pipe is pressurized or filled with water, or if it's a non-pressurized pipe, an open piping system, so basically does not have continuous water running through it. The tested and approved solution for these cases are extremely different. So for an open piping system, for example, you might require a much, let's say, stricter fire stopping material enabled for it to operate properly and give you the 2 hours fire rating. So it's also very important to also keep into consideration what these engineering judgments consist of and for what application they are being used. So for example, is it for a water supply pipe or is it for a drainage pipe as well? Does it work as well? So all of these are the different considerations that you might take. Now, I would like to thank you. I will hand over to my colleague Jad, where he will take you through the fire stopping with them.
Thank you, Wissam. I believe now Wissam provided us with a lot of information, and many of you might be asking, okay, why do we need this? How is it really related to BIM? So we'll show you now how Firestop can be really related to BIM and integrated in BIM, and what added value would it have in a construction project. So BIM, usually known as Building Information Model, can be also summarized, or it's known as Building Information Management. Why? Because when we say management, it helps us in managing and coordinating, collaborating, having better coordination between all stakeholders in the project. And as you can see here on the graph on the left side, whenever we have BIM, higher efforts, higher investments are done in the beginning phase of the project, and then it reduces gradually as we reach the ending stages of our project. However, in the traditional method, in any project that doesn't do BIM, you can see that the cost and charges and all the efforts increase drastically as we reach the ending stage of the project. That's why a lot of complications, a lot of issues will come up from the middle stages to the end of the project. Now, on the right side, the traditional method, any Firestop supplier would approach different contractors separately. There won't be any collaboration, any coordination between them. Having BIM, the Firestop supplier will be as a partner where he will have access to the model, everyone will have a clear idea, clear information, clear data will be available for all trades cooperating and working together. And that's why it would bring a lot of value and a lot of opportunities to save cost, to have better coordination and collaboration, and also for maintenance, which we will see and discuss in a bit. So what we usually see in a normal project where they don't use BIM when it comes to Firestop, many issues come up. For example, ordering the material, the deliveries, and taking off of the quantities, the logistics, everything is handled manually without any proper documentation. There's no transparency across the workflow. So no one really knows what exact quantity has been delivered to the site. What are the approvals used in this specific area? What are the documents that are already checked, approved by the consultant or not? Validation, for example, when the consultant has to do regular inspections at site for the openings and the applications that have been installed. This is done manually. And most of the time, the information, the data, the documents or approvals, or even the EJs are not ready in most of the time installation. The checking or the validation of this installation becomes very complex and time consuming. It's very important, or what we usually see also in most of the cases, that a lot of malpractices or wrong EJs are being submitted in the projects without having the proper documentation, the references to be checked, because it's a paper and no one has the access. All contractors or all stakeholders don't have the access for all the details clearly. And all trades are working separately. For example, you have the IF contractor or the main contractor, each one, or MEP contractor, each one doing his own work separately without any collaboration, everyone applying different material, different suppliers, where as per the UAE Code for Life and Safety, for example, there's something called the single source limitation. So if there's a big opening touching MEP with a joint which is covered by 2 contractors, it should be the same material. So there's no proper planning, and we don't know ahead of time if this is going to be there or not, unless it happens actually at site, and then there won't be proper solution for similar or such cases. Also, issues and solutions are not solved up front. So if there's a big opening with multiple services that are not coordinated properly, we cannot, or any supplier, Firestop supplier, manufacturer cannot provide a proper or suitable solution that is fire rated. Let's say then the contractor might go with a smoke seal solution that is not complying with the project requirement. So all these challenges and issues will definitely lead to loss of productivity across the workflow of the project, to higher costs, definitely. Risk and compliance is not properly managed in the project, and higher effort for execution and coordination. Now, what could be the benefits or the advantages of having Firestop in the BIM model, and how would it solve all these problems? So having Firestop with BIM will definitely have better idea of the approved design. Bill of material planning would be much better and improved. Productivity gain as well, which is something that all contractors would look for, and it would save a lot of money. And operation and maintenance for the facility management, and this is something important also for the building owners and developers. We will discuss each one quickly separately. So for the approved designs, having approved designs ahead of time, we will make sure that all the submitted documents, the EJs or the approvals, are code compliant, are safe, and are efficient as well, solutions to be applied in the project. And they would know exactly where is it going to be applied, for which exact opening, for which exact service. So no confusion will be there, and everything will be clear from the early stages of the project. Moving on to the bill of material for planning. So obtain quantities ahead of time for better planning to make sure that the material is available from the early stages of the project, and it would definitely help the contractor in planning their budget and the deliveries, because it's something we see a lot in the market, that whenever it comes to ordering the material of Firestop, no contractor has ever had this planned in his own budget. And they would say, we don't have budget for the Firestop, we cannot apply it properly, and then they would like will start to search for solutions that are not code compliant just to save a lot of money from because it wasn't planned properly. This way, it would stop a lot of these issues and problems in the market when it comes to bill of material and proper planning. Productivity gain. Looking at this graph, this is how usually Firestop is applied in a project. So each contractor or each application is applied after the services are installed. The EJ is requested after the services are installed, and it cannot be, no overlapping job could be ever done in a project without proper planning ahead of time. So that's why using BIM, you can see here in the lower table that overlapping of application can be done in a project without any complications. Different contractors working separately can apply the fire sealant at the same time without having any issues, without overlapping the execution, without having complications at site. And this way, they would definitely finish in a shorter period. And when we say that the project is finishing earlier, then definitely they will save a lot of money by the end of the day. Now moving on to operation and maintenance. For operation, it's always difficult for the contractor to know what is the right application for the MEP service they are going to install the Firestop solution for, definitely. So if they have a pipe, PVC pipe, it would be really difficult for them. Okay, where is the approval? Which approval or solution am I going to apply in this specific area or in the other area? They would call for the supplier. A lot of, let's say sometimes what we usually see also, some products are applied in the wrong places and then they have to rectify and change it, and a lot of cost is lost, and it's also time consuming as well for them to redo the job. It's a duplication of work. So this way, when we have the Firestop solution installed already or implemented in the BIM model, they would definitely know each approval or each solution for every separate service ahead of time before installing, and they can have it with them on their iPad or whatever technology they are using on the site, just by checking quickly and installing or making sure this is the right solution for the right application they have before installing and wasting their time. Also, when we say that the Firestop solution is integrated in the model itself, everyone will have the full details, or there will be proper documentation. Who installed the model? Who did the design? What's the approval? What's the product? When was it installed? Everything will be mentioned in the model directly. So all stakeholders will have a proper or clear idea of what's happening in their project. And this is something that building owners also would definitely look for, because it would help them in the maintenance later on. Let's say something wrong happens in the project and the pipe should be replaced after a couple of years, or there should be proper maintenance after 10 years and all the Firestop should be changed in the building for better safety. A new code came up. I don't know what might happen in the future. So if something should be changed, they would definitely have access to all the fixations, all the services, all the solutions provided and installed before in their project just by accessing the BIM model. So any building owner, for the maintenance of their project, they can know all the details, who installed it and what should be done, let's say if any additional maintenance is required over there. So we will summarize all these points in this graph over here. So as you can see, it definitely has a lot of benefits or adds a lot of value to the project. So if you look as a building owner or developer, it would definitely increase the quality of the building, and it would help them get as-built data for the facility management. Whereas for the engineering consultants, they will make sure everything is code compliant and as per the regulations, especially that here in UAE, civil defense is really strict about this topic. And improve designs and make sure that all the designs that are submitted are as per the requirements and optimized as much as possible. Also for the contractor, it's very timely, it reduces the time of the project and it helps them increase the job productivity at site. And everyone, all these stakeholders would have better coordination, definitely, optimized material and project cost. This is a quick briefing if the Firestop or when the Firestop supplier is part or a partner in the BIM model of the project, and when Firestop is integrated in the model in the very early stages of the project. So some of these pictures, this is how it would look like in a real case. And some of you might be asking now, okay, is this real? Is it the future? We never heard about it before. Was it implemented or done in any other projects? Well, yes, this has been done before and has been tried and implemented in more than one project. Now, I will share with you through the virtual reality room. I will switch my camera and I will show you an actual case where in a real project, the Firestop has been implemented in the model. Is it clear? So now I'm standing in the virtual reality room where you can see here behind me, it's an actual building where we have done the Firestop, where the Firestop has been implemented in the model. And if we move into the corridor, let's start with one example as the corridor, where most of, or all the projects, the corridor is the biggest part where Firestop is really required. All the corridor should be a safe exit for the people. So here in front of us, it's a fire-rated wall. You can see these are the MEP services. And here you can see the Firestop material around the pipes.
Excuse me to interrupt, but we cannot see
Yes.
anything on the screen. It's not showing anything. I'm not sure if you're sharing something right now.
I'm sharing the camera.
For me, it's not showing actually the camera. It's a closed sign for me.
Okay, anyone else is having this issue?
I think if you press on the bottom right, you can see a small picture of 3 walls with a projection on it. If you can try to press on that, I think it will maximize on your screen. Please let me know if it worked so we can just make sure that it's working fine.
Is it clear now? Anyone else is not seeing the camera where I'm standing?
Thank you. Yes, thank you so much. It seems it was only
Okay.
from my side.
Okay, thank you. So, for example, these are the MEP services, and you can see on the wall, this is the Firestop solution for the pipes, for the cable trays, for the ducts installed. And when we hide the elements like the wall or the pipes, we can show you the Firestop solution separately. And by clicking on the solution or the application here, we will definitely get all the details. What's the approval used in this area? Who installed it? When was it installed? And in case any additional comments, any pictures, when the consultant is doing the inspection, he can add additional comments in the model, so it will be saved for later maintenance or discussion with the client or the building owner. Moving on, also, as Wissam mentioned before, that Firestop is not only required for the wall, it's also for vertical applications. As you can see here, this is a shaft, and also Firestop is applied around the services, the vertical services in the shaft, and included in the model. And this is what we're showing you here. It's an actual project that has been done before. So the Firestop, as we go down in the shaft, every single floor, there's Firestop around the services. Now, moving on to the mechanical floor, where it's also a very congested area and a lot of services require fire sealant. So here in the mechanical floor, if we zoom out a little bit, okay, we can see here again, this is the Firestop around the services. Here on the top side also we have Firestop and colors around the pipes. And this is already implemented for all the services in the project. So now if we go out and look at the building, the full building, and we start hiding all the elements separately, and we keep only the Firestop products, we will definitely get all the products. We will take out the quantity, and we can see that with the click of the button, the contractor with few seconds will get the quantity of material required. So now all the elements are hidden, and all these points here, I'm not really sure it's very clear. All the points here are Firestop products that, or Firestop solutions that are implemented in the model. Okay, so you can see it now. I think there was an issue with the camera, and these small points, these are the Firestop solutions after we have hidden all the elements of the building. These are for the pipes, ducts, cable trays, everything already there. Now, during the presentation, the part of Wissam, he also mentioned that we have joints, we have MEP services, we have facade, we have membrane services. So we'll show you another example when it comes to light ventilated facade, that also the facade or the joints can be implemented, the Firestop can be implemented in the model. This is a building, and this is the cladding in here. We'll show you now the light ventilated facade solution, where we will zoom into the cladding. If we hide the element, you will see this red color. This is the Firestop already implemented into the model. And again here, by clicking on this solution, we will know all the details, all the history, and it could be integrated, or we can add QR codes next to it. So while the consultant is doing inspections or anyone is checking at site, he will scan the QR code next to the Firestop solution, and it will take him directly to the area and the model where he will get all the information and the details. This was it from our side for Firestop with BIM. I hope it was interesting, and we are ready to hear all your questions if you have.
Thank you so much, Engineer Jad. It was really amazing presentation. Thank you also so much for Engineer Wissam. If anyone has a question, I suggest that they can either write it in the chat, or maybe they can raise their hand. Which one would be more convenient for you?
Anything. Whoever wants to speak, please go ahead.
Okay, yes, please go ahead, who has a question.
Yeah, I have one question.
Yes.
My name is Michael from B6 Group, and I just want to understand one thing which is related to the main contractor mainly, and you mentioned it, the bill of quantities or the quantities itself. How I can, or how this method can help me in the quantities. I mean, if I implement UL system and it's repeated 17 times, so this will transfer to how many colors, how many sealant I need, how many cartridge, or how many sausage, or how many drum, or just how many EJ I have, or sorry, how many UL I have. And is any transfer between the UL and the quantities, or just it's quantities number of the UL? Is my question clear?
You can get both. You can get the details of the UL systems or the EJs, okay? And definitely you will get the quantities of the product. So as you mentioned, what product are you going to use? Separate different items for different solutions, and how many pieces of each item you require for your project.
So this means if I have CB606, which will use for the doors, it will be transferred directly to the how many sealant sausages or how many cartridge I needed.
We can calculate from the model, definitely. It's a nice question. Thank you so much.
Can I
Thank you very much, Michael, for your. Yes, I want to add something because you mentioned something very important, because you said, does it also record like how many systems do I have or how many engineering judgments? Most importantly, I'm sure you, it seems like you have a lot of experience in Firestop, but I'm sure you know that engineering judgments are usually very difficult to install and they could be very expensive. So I think a very important part here is that once you are able to model the fire stopping system beforehand, during the design stage, you are able to eliminate and reduce a lot the number of engineering systems that you might have, which will help you later on with price and productivity.
I hope, but in my current project, I reached to 212 EJ, not UL, 212. Especially, I have a lot of house of expertise crying with me, but that's the life.
So if you want, Michael, I can share my number here in the messages. Okay, we can discuss more about this and explain to you how this could be solved in your other projects.
Perfect, because to be honest with you, I see on the screen the solutions is for individual, not for combo. So I think it will be difficult if we reach to the combo, because if I reach to the combo system and I need grout with sealant, with strip, with color, with pillow, so it will be manually.
Now you're going the extreme solution.
My yeah,
the worst case.
To be honest with you, the EJs that I have all, it's mostly for the electrical rooms, for the corridors, which is more complicated, which was PVC, no more annular space, you know.
Exactly. That's why when it's done using the BIM ahead of time, sometimes also as a Firestop supplier, we would definitely advise the customer while they are doing the coordination of the services that, okay, if these services are installed in that way or in a different way, this would be a solution that you can use instead of going with a very complicated EJ. And it's something, that's why I mentioned my number here in the message, because I would like to explain more about this with you and discuss it.
Okay, noted.
Hello, Engineer Saman.
Thank you so much for your question.
You're welcome.
Engineer Saman?
Any other questions?
I think I heard somebody asking for Jad, but I'm not sure. It was quite far away.
Engineer Jad, can you hear me?
Yes.
Jad, this is regarding the engineering judgments that we normally receive. Okay, myself Tushar from Al Nabuda Group, firstly. And my concern is regarding the engineering judgments that we receive as a part of your material, and we also get your standard Excel data sheets from where we can get the quantity of the material that would be required. Now, I would like to particularly focus on one thing. When we are making our in-house BIM models, is there a chance or possibility that we receive a family of the like family in terms of Revit model that I'm talking about, that we receive families of the engineering judgments that have been proposed for a particular project, so that we in-house can incorporate this into our models?
Yes, this is a good question. We have the families, but I think maybe as per the discussion with Dr. Ali, we cannot speak more about the services and what we do as when it comes detail about the products. So if you want also, I can send you and we can have a detailed presentation about this. What could be done either by providing families or by other services, we can do it for you as Healthy. I'm not sure if you were aware about that before.
Not really.
Okay, so if you can also share your number and we can do a detailed presentation about these services, how we can do it either by sharing the families with you, your team would do it, or as Healthy, we have the option of, we have our dedicated team for BIM and we can do it for you.
Thank you, Jed. I'll get back to you on this. I have your number.
Okay. You're welcome. I think no more questions. So thank you so much, everyone, for attending. Thank you, Anna, Dr. Ali, and Noura for your support and giving us this opportunity. And I hope it was interesting for everyone.
Thank you very much for this opportunity, and it was a pleasure presenting to you all.
Thank you so much for presenting. It was really amazing, and thank you for everyone for joining us. The webinar will be uploaded soon on our website, so just please visit us later on.
Thank you.
Thank you very much.
Thank you. Bye bye. Have a nice day.
Bye bye.
Bye.
Thank you, team.